here we go. Exponential graphs. There are things about an exponential graph that will always be the same, kind of like a parabola is always the same basic shape. It's always a U shape of some kind. Absolute value is always a V shape of some kind. An exponential always has the exact same shape. You just move it and slide it around, but it has the same basic shape. So we want to talk about that today. So an exponential is this format. It has an A in front. It has a base that's in parentheses, and it has an x. The x is always the exponent. That's why it's called an exponential, because it has an x in the exponent. Okay, the thing that will always be the same about an exponential graph. The first thing, number one, is that the asymptote is on the x-axis. What does it mean to be an asymptote again? What is an asymptote? Say that again. It almost touches, right? It almost touches, but it doesn't. And so this means this graph almost touches the x-axis, but not quite. So the asymptote will always be on the x-axis. All right, number two. It will cross the y-axis at 1. And that will always be true also. And then there's a third quality about an exponential graph. It will curve steeply through the b value, whatever the b value is in your equation. All right, those are the things that will always be the same about an exponential. So I'd like you to go to a grid now, and we're going to draw the things that will be the same about an exponential graph. All right, so here's my first grid. Go ahead and highlight an asymptote across the x-axis. All right, so we're going to get really close to that x-axis, but we are not going to touch it. And so as we draw a graph that gets really close to the x-axis but doesn't touch it, it's going to look something like this. It'll stay really close to the x-axis until it starts to curve away towards the number 1. And all exponential graphs do that. They hug that x-axis really close until they start to curve toward the y-axis, and they cross the y-axis at 1. After that, they start to curve steeply in a positive direction. And the curve, the steepness of the curve, is going to depend on the value of b. If the value of b is 2, then it'll curve through the number 2 like that. If the value of b is 3, it will curve through the number 3. If the value of b is 4, it will curve through the number 4. Can you start to see the pattern here? So it starts to fan out. But the curve, the steepness of the curve, depends on the number that's in the parentheses. That's why I was saying parentheses are important, so you can always tell what the number is. The a value will do something different to the graph. We're not going to focus on that just quite yet, but we want to focus on that. So we're going to practice a couple of these graphs a minute. All right, so I'm going to slide over, and I'd like us to do y equals 1 parentheses 4 to the x. Now that 1 isn't always there. So a lot of times that 1 would just be just a blank, but we understand that the number 1 is there. That will not affect the graph in any way right now. And so your first thing is to say, oh, that's an exponential, and I know the shape of an exponential. And so the first thing you'll want to do is draw your asymptote. The asymptote will be on the x-axis. That'll be your reminder. Don't touch the asymptote. Then you'll start drawing, and you'll hug your asymptote super close. And you'll head for the number 1, which is on the y-axis. And then you'll bend and you'll turn, and what number will we be aiming for here? 4. And so we'll aim for the number 4. We label it on our graph. It's always one square away, or one width away, but we head towards the number 4. Oops, that wasn't a very good drawing. And there's your graph, and that's an exponential graph. So they're not hard to create. Every exponential graph has a domain of all real numbers, and the reason that it has domain of all real numbers is because there's no square roots and there's no denominators. And if there's no square roots and there's no denominators, then the domain is all real numbers. The range still follows the rules of minimum to maximum. So what is the minimum for this graph? What will it be? What's the lowest it would ever be? Or close to 0. Will it ever touch 0? No. So then my range doesn't have the bar underneath it. And then y, and then the maximum is heading towards infinity, and so the range is infinity. Okay, any questions on that? Good so far? Okay, let's try another one. So how about y equals parentheses 3 to the x, and then let's put a negative in front of that. All right, well, we recognize it's an exponential shape, so we draw our asymptote first, always on the x-axis. So highlight that asymptote. We draw the beginning of this function, hugging that asymptote and curving toward the number 1, and then aiming toward what point next? 3. Okay, aiming toward the number 3, and so we draw that curve. That is the normal position of this exponential. But the negative has a job to do, and it tells us to do what to this graph, just like it told us to do with every other graph we've done. Flip it. In what direction? Over the x-axis, upside down. And so this thing is going to flip completely upside down, and so it'll hug the axis on the other side. It'll go through -1 and -3, and it would be reflected completely upside down. And that would be the position of the graph. So I can go ahead and maybe erase the graph I'd originally drawn. Okay, then we think about, well, what's the domain for this? The domain is still all real numbers. Okay, the domain is not going to change. No matter how we flip or slide or move this, the domain will stay all real numbers. The range will change, however. The range has a different low now because it's been flipped upside down, so -infinity is my lowest point and less than y, and my highest point is now 0, but I don't include the equal to bar under either of those because I don't touch -infinity and I don't touch 0, and those are the way those are framed there. Okay, any questions about that? Okay, let's try another one. Okay, how about y equals parentheses e to the -x? This is a famous exponential also. Again, remember there's the number 1 in front of these. All right, so draw your asymptote. It's always part of the graph. And then we hug the asymptote. And we curve toward 1. And this is where it gets kind of interesting. Last time we curved toward 4 and we curved toward 3. What do we curve toward for e? Does anybody know actually what the number of e is? It's not 1. It's 2.7-ish. It's 2.7. All right, so we need to aim our best for 2.7. So do your best. But make sure it's not 3 and it's not 2, but somewhere in between. And so you're aiming for 2.7. And then you will curve through that. Okay. And so when we label it on your graph 1 and then 2.7-ish, approximately. It's 2.714, blah, blah, blah. Okay, but what does the negative in this problem do? If it's not in front, then what does it do? It's a sideways reflection. Okay, everything in quadrant 1 and 2 flip each other over. And so I'm going to now flip, to the other side, and I'll have my 2.7 be on the opposite side. My 1 stays the same, and so my curve is going to come and hug the asymptote on the other direction. My domain doesn't change. My domain is still all real numbers. My range, I just think what's the lowest it would get. It's not going to touch it, but my lowest it would get would be 0. And my highest is infinity. Okay, how you doing so far? Following it okay? What else do we do to graphs besides reflecting them? We translate them sideways or up or down, right? Sideways or up or down. Okay, so I want to go back to our notes where we were taking notes. And if you want to move these graphs either sideways, side to side, or up or down, then the equation will be A parentheses B, and then you'll have, x minus h in the top and plus k in the bottom. The minus h is the side to side, and that's always the opposite. If it's plus, then it's left. If it's minus, it's right. It's always opposite, just like with a parabola, just like with absolute value, just like all the other ones we did. If the side to side one, the left right, is always opposite. The one that's on the bottom, the plus k, that's just not in the power, but in the same line as the rest of the problem, that's going to move something up and down. So we're going to practice a couple of those. All right, so our, I guess, fifth example. So y equals parentheses 5 with a negative in front, and then x minus 2. The x minus 2 is in the power. So first thing you'll want to do is you'll want to recognize that it is needs an asymptote. When you get good at these, you can do just draw the reflection right at the same time. You say, oh, I know this is going to reflect, so we can go draw our reflection automatically. So the reflection will come, curve through 1, and then also through 5. So I drew the graph and its reflection at the same time. My last thing would be to move this sideways. Okay, now specifically, which direction, left or right? Right, how many? Right, 2. Okay, I know it's right because it's part of the exponent, and I know it's 2 because the minus 2 tells me that I'm going to go in a right direction. So I want to pull this graph to the right 2. So each dot just moves over 2 units. All right, and then we'll come down, and then our graph will be just 2 units over from where it was. So the red graph is the position of the final graph. And so you could highlight your final one, or you could go back and erase the other one if you wanted, just to be clear about what's what. The domain for this one, still all real numbers. And the range for this one, its lowest value is down at negative infinity, and it won't ever get any higher than 0. All right, let's try one that looks like this. All right, y equals 2 parentheses 3 to the x minus 4. All right, now here's something different. Well, besides the minus 4, what else is different that we've never seen before? The 2. Okay, this is a stretch. I don't mean like this is going to be a stretch for you academically. I mean like literally this is going to be a stretch on our drawing. Okay, but we still approach it the same way. We still get our asymptote in the right place. Okay, so asymptote along the x-axis. We focus on the number 3 first, and so we're going to hug our asymptote, and we're going to curve toward 1, and then we're going to curve toward 3. All right, now the stretch. Okay, the stretch is that number 2 right there. What a stretch does is it takes the dots, not the asymptote, but it takes the dots, and it's a multiplier. It's a doubler. Because it's a 2, it's a multiplier by the number of 2. And so we take those numbers, and we say, well, this used to be at 1, and that was at 3. I need to double those. And when I double them, they're going to be at 2, and they're going to be up here at 6. Because that's double, whoops, 6's right here. Okay, double what they were. So I'm going to put my new twice as high. It used to have a height of 1, now it has a height of 2. The other one used to have a height of 3, now it's going to have a height of 6. And so that's what that stretch does, just like it did with other graphs we worked on. Okay, all right, so I'm going to erase my previous one so it's not in the way here. And then I'm going to draw my new one. So I'm going to hug the asymptote here. I'm going to come through 2 and curve through 6. And the last thing I'm going to do on that is drop the whole thing down 4, including the asymptote. The asymptote drops down 4, all the dots drop down 4. I'm not in Notability right now, so I can't use my scissors and drag it down, but you guys can. Use your scissors, drag the entire thing, including the asymptote, and drop the whole thing down 4. I'm going to have to redraw mine. That's okay, I don't mind. So I will redraw, and my asymptote will move down here to the number 4, down 4 squares. So I'll erase my old asymptote. Okay, so my old asymptote's gone. My other dots are going to move down 4. So they'll be down 4 and 1, 2, down 4. So I still have to hug my new position of my asymptote and then curve through the new dots that were moved down by 4. And then I'll erase my old one. Okay, so this does not affect the domain. The domain is still all real numbers, the same as it has been the whole time. But it affects my range. And so my domain is still all real numbers, but my range is something different. My range now has a new low number. What is the lowest number that I will get to but never cross? Yeah, so my new range is -4, and my highest is still heading up towards infinity through those the direction of that exponential graph heads up in that northward direction. Okay, any questions about that? Oh, you're packing up. Okay, I had one other thing I just wanted to show you, because you're going to see this kind of question. How do you graph a half? Half is a math fact. Tell me the math fact for half. 2 to the what? 2 to the -1. You have to change it to its math fact first, and then combine the -1 and the x to make it 2 -x. That's what you're going to graph. Okay, so it's not half. You're going to change it to its math fact and then graph it. You can't graph fractions. They have to be changed to their math facts first.